Then when we talk about derivatives, we're actually taking x to 0, because again, it's like the run we're making get smaller and smaller and smaller, almost to 0. But again, we can't technically make it equal 0. So this is just the notation. Okay? Yes.
What do they mean by convergence?
Convergence meaning that if you went back, like we said, the slope of this was equal to 2, and then the slope of that line was equal to 1.5, and then the slope of another line was 1 1/3, and then the slope was 1 1/4, and the slope. And so as we got closer to that single point, it's converging, meaning getting close to 1. And then after a certain point, we just keep getting the answer 1 over and over. So f of x, if I say that's 2x plus 3, let me make it squared just so we have something a little bit funner to play with. Right? So it's kind of going like that. Now, all they're saying, and I think we talked about this a little bit, there's x. And if I move it over h amount, then I have x plus h. And I'm finding the slope between those 2 points. What slope? Difference in y values divided by the difference in x values. So here, the slope is equal to, well, I would say, and let me just make this very clear, x1, sorry, x2, y2, x1, y1. So the slope is the difference in y values. Well, this y value is x plus h squared plus 3. Now, do you get where I'm saying that?
Yeah.
So we have y2 minus y1. So there's y2. I put this x value into the function. And then I'm going to subtract, putting x into the function. So I just have x squared plus 3 divided by, we subtract the x values on bottom. So we're saying x plus h minus x. And if I kind of take that and look back at this formula, x plus h minus x will always be like that, and therefore x minus x will always cancel, as we just have that difference, h. And the thing on top is basically your y2 minus your y1 value. Okay, so this is the actual definition of the derivative. This is how we get the derivative. If I now multiply all this out and simplify, we're going to come up with 2x, which we now know shorter methods for finding the derivative of that. But if I do all this algebra out, it's going to simplify down to 2x. The other thing just from this section, don't forget dy dx and f, like what we call prime, are the notation for derivative. So we've done all of that. Then the derivative is interpreted as the gradient of the function. Do we understand what that means?
The gradient.
Yeah, the derivative. Interpreting the derivative is the gradient of the function. and as a rate of change. Now, I would say that and this next one are two areas of like, well, definitely this first part is just how well you understand the concept. And then the second one is applying a bit of algebra. So if you think back to, again, going back to Usain Bolt, right? So there was the graph of him running. And what did we do? We kept getting points and getting points until we found out that, right? And so the slope right there, let's say it equaled 10. But what does that 10 mean?
Also doing it the other way around?
Not quite. But if we found out that this was 10, now think about it. This was the distance, 100 meters. This was the amount of time he took. Right? Down here, this might have had a slope of 2.5. So what's the difference? Or what is that telling you?
It is accelerating. Oh, then he's going faster.
He's going faster. Yeah. The slope is his rate of change, which in a distance time is like his speed. Down here, he was only running 2.5 meters a second. Here, he's running 10 meters a second. And so that's this idea, interpreting the gradient as a rate of change. And it could be a question about germs or, organisms multiplying. And you're saying they're changing at a rate of 20 cells per second. And so that's what the gradient and the derivative tell you. And we'll try and give you an example of that kind of question. Tangents and normals and their equations. A tangent or normal is straight line y equals mx plus c. So when they talk about the equation of the tangent or the equation of the normal, now there's that form, which I know pretty much everybody knows and likes. There's, I think this is totally acceptable and less work form, which is y minus y1 x minus x1. Now, you can write that as your equation of the line, and it will be totally acceptable. And you'll see that it's actually, less work than having to do this. But I know everybody is happy with y equals mx plus c, so we'll stick with it. But yes, finding the tangent, finding the normal requires something like that.
So that's their equation.
Yeah. Basically, they're straight lines. And so we have to talk about, filling in for x and y, like finding c here. You'd have to know the slope, and then you'd have to find c. Here, you still have to know the slope, and you have to know at least one point. On this side, this is kind of like the little extra notes for these parts. So you do need to identify when a function is increasing or decreasing. And that's based on either looking at the function, if you can draw the graph of it, or the derivative, because a positive derivative is increasing, a negative decreasing. 0 is neither increasing or decreasing kind of thing. Use of both analytical and technology, meaning, yeah,